Hello, and welcome to Venture Deep. Tonight, we will be drifting into what causes a tsunami. Sit back and relax so I can take you on a gentle ride where nothing else matters. A tsunami is among the most fearsome and awe-inspiring natural disasters that our planet can unleash. A phenomenon that emerges not from ordinary winds or surface storms, but from the restless movements and sudden disturbances within the Earth itself. And to understand what causes a tsunami, we must peer into the secret mechanics of our planet, where invisible pressures accumulate over centuries and erupt in seconds, sending waves racing across the oceans with devastating power. For unlike the rolling surf we see on beaches, which are formed by winds sweeping across the sea's surface, a tsunami is a displacement of the ocean itself, a vast surge of water set in motion by violent shifts that occur deep beneath the waves, most commonly triggered by undersea earthquakes. When colossal tectonic plates, those giant slabs of the Earth's crust, grind against one another in silence until the accumulated stress becomes too great to contain. And in that fateful moment, the seafloor may suddenly rise or fall by meters, shifting billions of tons of seawater all at once, and the ocean responds instantly, sending ripples that expand outward in every direction, moving faster than commercial jets, carrying energy that can cross entire ocean basins without losing strength. And though earthquakes are the most frequent source, the story of tsunamis is not bound to them alone. For volcanic eruptions, sudden landslides, and even cosmic collisions have also been capable of awakening these towering walls of water. And in some of the most catastrophic moments in Earth's history, such forces have reshaped continents, erased coastlines, and forever altered human lives. When we think of a volcano, we imagine fire, smoke, and lava. Yet beneath the waves, volcanoes can be even more destructive in subtle and terrifying ways. For when an undersea volcano erupts, the collapse of its caldera or the explosion of its cone can displace unimaginable amounts of water, creating rippling waves that grow into a tsunami as they journey outward. And when land-based volcanoes erupt near the sea, they can hurl massive chunks of rock into the water, sending sudden pulses across the ocean surface, or collapse in fiery landslides that crash into the waves, creating disturbances powerful enough to rival those from earthquakes. And in all these cases, it is the sheer force of displacement, the sudden removal or addition of enormous volumes of water that makes the ocean respond violently. A reminder that tsunamis are not a singular phenomenon with one cause, but rather a result of different catastrophes converging on the same effect, the stirring of the entire sea. Another cause lies hidden in the instability of Earth's underwater slopes, for the ocean floor is not flat but carved with valleys, mountains, cliffs, and ridges. And when earthquakes, eruptions, or even gradual buildups of sediment destabilize these features, gigantic landslides can cascade downward into the abyss, displacing enough water to send waves careening toward distant shores. And though not as common as seismic events, these underwater landslides can be devastating because their onset is sudden, their signals subtle, and their energy immense. And in many ways, they show that the Earth itself is always in motion, always rearranging its surface. And in that shifting lies the possibility of calamity, even more rare, but perhaps most terrifying in scale. is the potential for cosmic impacts to cause tsunamis. For history tells us that Earth has been struck before by asteroids and comets plunging into its oceans, and the energy of such an impact, transferred instantly to the sea, would send waves higher than skyscrapers across entire basins, devastating continents, erasing coastlines, and altering climates. And while such events are exceedingly uncommon, the possibility remains, reminding us of the vulnerability of our planet, not only to internal forces, but also to those from the heavens. What makes tsunamis especially dangerous is not only their violent origin, but also their deceptive nature. Because in the deep ocean, where the water can be several kilometers thick, the waves of a tsunami may be almost invisible to the human eye, appearing as nothing more than a gentle rise in the surface, perhaps a meter or less in height, yet traveling at the speed of a jet airplane and with wavelengths stretching for hundreds of kilometers. And as these waves travel vast distances, crossing seas in a matter of hours, they carry with them colossal amounts of energy, waiting only for the shallow slopes of a coastline to reveal their true character. For as they approach land, the ocean floor rises, the wave slows, and its energy is compressed into height, transforming an almost invisible ripple into a towering wall of water that can surge inland for kilometers, obliterating villages, cities, and landscapes in its path. And this transformation from silent traveler to roaring catastrophe is what makes the tsunami one of the deadliest of all natural hazards. In understanding the causes of tsunamis, scientists also seek to unlock the mysteries of Earth's inner workings. For every undersea earthquake is a reminder of the tectonic forces that have shaped continents and oceans over millions of years. Every volcanic eruption, a glimpse into the fiery heart of our planet. Every landslide, a sign of the fragile balance of Earth's surface. And every potential asteroid, a symbol of the universe's randomness and our place within it. And by studying these events, deploying sensors across the seafloor, using satellites to detect tiny changes in the ocean's surface, and monitoring volcanic and seismic activity, humanity strives to create warning systems that can provide precious minutes or hours of time to evacuate coastal areas before disaster strikes. Because while we cannot stop the movements of the Earth or the impacts of the cosmos, we can learn, prepare, and respond with wisdom and foresight. The causes of tsunamis, therefore, tell a story, not only of destruction, but also of connection. For they reveal how the shifting of rock miles beneath the ocean, or the eruption of a volcano thousands of kilometers away, or the collapse of a mountain under the sea, can ultimately affect human lives in distant lands, binding together geology, oceanography, and human history in one immense web of cause and effect. And through this story, we are reminded that the Earth is alive, restless, and always in motion, and that our oceans, though often calm and life-giving, hold within them the memory of ancient cataclysms and the potential for future upheavals. And thus to ask what causes a tsunami is to ask about the forces that shape our world itself. Forces that operate on scales beyond human imagination, yet touch human existence in the most profound of ways. And so the answer is not simple, but layered with earthquakes, eruptions, landslides, and impacts, all converging in one truth, that the sea, when stirred by the Earth's power, can rise against the land in ways both terrible and unforgettable, reminding us of the fragile line between safety and catastrophe, between calm and chaos, and between the silence of the deep and the roar of a wave that has traveled across an ocean to find its end upon our shores. The hidden birth of tsunamis. A tsunami is not born from the wind that stirs the surface of the ocean, but from the restless depths of the earth, where colossal forces gather silently until they erupt in sudden fury. Unlike ordinary waves, which dance across the sea with the rhythm of breezes, a tsunami is a displacement of the ocean itself, a mass of water shoved aside by movements so vast that the sea becomes a weapon of destruction. These waves begin quietly, often far from the shore, triggered by an unseen event deep below. The most common cause is the shifting of tectonic plates along fault lines, where pressure builds for decades or even centuries before being released in an instant. In that moment, the ocean floor may rise or fall by several meters, pushing or pulling billions of tons of seawater. That sudden motion sends ripples of energy racing outward, traveling across vast distances at speeds that rival passenger jets. Yet, in the open ocean, these waves can be nearly invisible, a gentle bulge that passes unnoticed. It is only when they reach the shallows of coastlines that their hidden power is revealed. The causes of tsunamis, therefore, lie in the intimate relationship between Earth's geology and the ocean's vast expanse, a reminder that the sea is never entirely still, but always listening to the shifting of the ground beneath it. The earthquake. The most common and powerful cause of a tsunami is an undersea earthquake, a sudden shift along the boundaries of tectonic plates. These massive slabs of rock, which form the surface of our planet, are constantly in motion, colliding, grinding, and sliding past one another. Along subduction zones, one plate is forced beneath another, and over centuries, this slow motion creates unimaginable tension. When that tension can no longer be contained, the seafloor snaps, moving abruptly in a single violent moment. If the seafloor thrusts upward, the ocean above it is lifted as well. If it drops downward, the water rushes to fill the gap. In either case, the result is a tsunami. The energy released is staggering, enough to hurl waves across an entire ocean basin. Earthquakes along the Pacific Ring of Fire are especially notorious for producing devastating tsunamis, as history has shown in Japan, Indonesia, and Chile. The suddenness of these events makes them particularly deadly, for they offer little warning to those living near the coast. Scientists place seismographs and sensors along fault lines to detect these quakes. Yet, even with technology, predicting exactly when one will strike remains impossible. Thus, the earthquake remains the primary and most feared trigger of tsunamis. Across the globe, volcanic eruptions beneath the volcanoes, though fiery and dramatic on land, can be even more destructive when they erupt beneath the ocean's surface. The sudden explosion of magma, gas, and ash can displace water violently, sending waves outward with deadly force. When the roof of a submarine volcano collapses into its chamber, the sea above it plunges downward and then rebounds, creating ripples that can swell into tsunamis. Even on land, volcanoes near coastlines can cause waves by hurling rock and debris into the sea or by collapsing portions of their structure into the water. A single landslide, triggered by volcanic activity, can shift millions of tons of material in an instant, enough to unleash towering waves. History remembers eruptions like Krakatoa in 1883, which sent waves more than 40 meters high racing across nearby islands, killing tens of thousands. Such events remind us that fire and water are not separate forces, but often intertwined in destruction. The causes of volcanic tsunamis highlight how the Earth's fiery heart beneath the crust can awaken the oceans above, linking the molten depths to the restless waves that sweep the land. The role of landslides: the Earth is constantly reshaping itself, and sometimes this reshaping comes in the form of massive landslides, both above and below the ocean's surface. When enormous masses of rock and sediment tumble into the sea, the displaced water surges outward, creating waves that may travel far beyond their origin. Undersea landslides can occur when slopes on the ocean floor become unstable due to earthquakes, volcanic activity, or even the slow accumulation of sediment until gravity finally wins. Though less common than seismic causes, landslide-triggered tsunamis can be particularly severe near coastlines, where the sudden influx of displaced water leaves little time for escape. Some of the tallest waves ever recorded were caused by landslides rather than quakes, such as the 1958 Litua Bay event in Alaska, when a massive rockfall created a wave over 500 meters high that stripped entire mountainsides bare. These rare but extreme cases remind us that tsunamis do not always require massive global events. Sometimes, a single mountain slope breaking loose is enough to rouse the sea into violence. The role of landslides in generating tsunamis shows how fragile the balance of Earth's landscapes truly is. The rare impact of asteroids, though extraordinarily rare, one of the most dramatic causes of a tsunami is the impact of an asteroid or comet into the ocean. When a massive space rock collides with the sea, the energy transferred is staggering, capable of sending waves higher than skyscrapers across vast distances. While modern history has not witnessed such an event, geological records and computer models suggest that past asteroid impacts may have caused megatsunamis that reshaped coastlines and devastated ecosystems. The sheer scale of such a wave defies imagination, as it would not only destroy coastal regions, but also alter weather patterns and even global climates. Scientists keep a close watch on near-Earth objects, aware of the catastrophic potential of such collisions. Although unlikely in our lifetimes, the possibility remains, reminding us that Earth's vulnerability extends beyond its internal forces to those that travel silently through space. The asteroid impact is perhaps the rarest but most extreme cause of tsunamis, a cosmic reminder that our world is part of a larger, often unpredictable universe, where the sea itself can be turned into an agent of destruction from above. The journey of the waves. Once a tsunami is born, it begins a journey unlike any other wave on Earth. Unlike the short, choppy waves driven by wind, tsunami waves can stretch hundreds of kilometers from crest to crest. They travel across deep oceans at speeds exceeding 800 kilometers per hour. Yet, in open water, their height may be less than a meter, making them nearly impossible to detect with the naked eye. Ships at sea often pass over them without realizing a wave of destruction is moving beneath them. What carries them is not the movement of water itself, but the transfer of energy, a ripple of force surging outward in all directions. This energy can circle entire ocean basins, bouncing back and forth for days. It is only when these waves approach shallow water near coastlines that they begin to change, slowing down, compressing, and rising upward into walls of water that can reach terrifying heights. The journey of the tsunami is a story of hidden motion, of a silent traveler that carries destruction far from its birthplace, reminding us that what begins in one corner of the earth may end in tragedy thousands of kilometers away. The silent threat in the deep. What makes tsunamis uniquely dangerous is their invisibility in the open ocean. Unlike hurricanes or storms, which announce their approach with clouds and winds, a tsunami can travel undetected beneath the calmest seas. Its long wavelength and low amplitude make it nearly invisible to observers, yet its energy is vast, spread across entire ocean depths. This deceptive nature means that by the time a tsunami is recognized from shore, it may already be too late to flee. Even modern sensors and satellites can sometimes struggle to track their full path, especially when the triggering event is complex, like a landslide or volcanic eruption. For communities without early warning systems, the first sign of an approaching tsunami may be the sudden retreat of the ocean, as water pulls away from the shore before surging back with deadly force. The silence of the tsunami's journey is part of what makes it so terrifying, for it hides immense destruction behind a mask of calm, only to reveal itself in moments of chaos when the waves finally strike land. The coastal transformation. A tsunami reaches shallow coastal waters. Its true character is unleashed. The wave slows, its wavelength shortens, and its height increases dramatically as the ocean compresses its energy into a towering surge. This is the moment when destruction becomes unavoidable. The sea may recede suddenly, exposing reefs, fish, and the ocean floor before returning with overwhelming force. The first wave may not be the largest. Often, successive waves grow taller and more destructive, catching survivors off guard. As the water surges inland, it destroys everything in its path, sweeping away homes, vehicles, forests, and even reshaping the coastline itself. After the water retreats, the land it leaves behind is unrecognizable, scarred by erosion, debris, and loss. Coastal transformation is both physical and human, as communities are left devastated, landscapes altered, and memories marked forever. The shoreline becomes a place where the hidden forces of the earth and sea converge, leaving behind a reminder of nature's unstoppable power. The lessons of history. Throughout history, tsunamis have left an indelible mark on human civilization. From ancient legends describing walls of water that swallowed entire cities to modern tragedies witnessed on live television, the story of the tsunami is one of repetition and remembrance. The Indian Ocean tsunami of 2004, the Japanese tsunami of 2011, and countless smaller events across centuries remind us that these disasters are not distant possibilities, but recurring realities. Each event teaches lessons about preparedness, warning systems, and the resilience of human communities. Scientists study the geological and historical records to understand how often tsunamis strike and what patterns may exist. But the randomness of Earth's processes ensures that no coastline is ever fully safe. The lessons of history are etched into both the land and the human spirit, reminding us that while we cannot stop tsunamis from coming, we can prepare, adapt, and respond with greater wisdom for the future. The connection between earth and sea. The heart of every tsunami lies the connection between Earth's geology and the ocean's expanse. A shift deep within the crust, a fiery eruption beneath the waves, a mountain collapsing into the sea, or even an asteroid from the heavens. All of these can awaken the ocean into destructive motion. The causes of tsunamis remind us that the Earth is not static, but alive, dynamic, and constantly reshaping itself, and that the ocean is not passive, but deeply responsive to the planet's movements. This connection binds the fate of human civilizations to forces far greater than ourselves. By studying these causes, building warning systems, and respecting the signs of nature, humanity can hope to reduce the toll of future disasters. Yet, the connection remains a powerful reminder that we live on a restless planet where land and sea are in constant dialogue, and where the balance between safety and catastrophe can shift in a single moment. The science of seafloor shifts beneath. The ocean's surface lies a restless landscape of ridges, trenches, and fault lines that constantly reshape themselves. When pressure along these boundaries becomes too great, the seafloor may rupture in violent motion, lifting or dropping massive areas of rock. This sudden shift is the spark that sets a tsunami in motion, for the water above has no choice but to follow the land beneath it, unlike wind-driven waves, which only disturb the surface. This displacement extends through the entire water column, creating a ripple of energy that radiates outward. The science of seafloor shifts teaches us that the ocean is not an isolated system, but one deeply connected to the geology beneath it. Instruments placed along the seabed now monitor even the tiniest tremors, offering scientists clues about where the next tsunami may originate. But even with all this technology, the raw power of Earth's shifting crust reminds us that humanity is only a witness to the ceaseless changes happening below. The role of subduction zones along the edges of continents. Lie subduction zones, places where one tectonic plate slides beneath another into the mantle. These zones are hotspots for the largest earthquakes and tsunamis on Earth. The pressure here builds silently for centuries until released in a colossal quake that can alter coastlines in minutes. When the upper plate rebounds after being dragged downward, it lifts the ocean floor, and the sea above it rises in kind. Such events can trigger waves that cross entire oceans, striking distant shores long after the quake itself has ended. The devastating 2011 Japan tsunami was born from such a subduction zone event, proving how destructive this mechanism can be. Scientists focus much of their study on these regions, knowing that they are the primary source of the world's deadliest tsunamis. The role of subduction zones in causing tsunamis underscores the deep connection between the shifting of continents and the rolling of the seas. Volcanic islands and collapse events. Volcanic islands are dramatic reminders of the Earth's ability to create land from fire, yet they also hide the potential for destruction. When part of a volcanic island collapses into the ocean, the displaced water can generate enormous waves. These events often follow eruptions, when unstable rock and ash lose their support and cascade into the sea. The collapse of volcanic flanks has been responsible for some of the largest local tsunamis in recorded history. The geology of volcanic islands makes them prone to sudden change. Their steep slopes and fragile layers vulnerable to erosion, earthquakes, and explosive blasts. These collapses may not always make global news, but for nearby communities, they can be catastrophic. The link between volcanic creation and tsunami destruction reveals how the same forces that build beauty in nature also hold the power to destroy it in an instant. The hidden power of underwater eruptions far beneath the waves. Volcanoes erupt in silence, unseen by human eyes. These submarine eruptions can be immensely powerful, sending plumes of ash and rock through the ocean and triggering violent displacements of water. The hidden power of these events lies in their secrecy, for they often occur without warning and far from monitoring stations. Some undersea eruptions are so massive that they reshape the seafloor itself, raising new islands or collapsing entire structures into the abyss. The waves they produce may start small but can grow rapidly as they interact with coastlines. The eruption of the Tonga Ha'api volcano in 2022 reminded the world of the destructive potential of underwater explosions, sending shockwaves and tsunamis across the Pacific. These hidden events remind us that much of the Earth remains unexplored and that the ocean still conceals forces capable of sudden and massive change. The energy behind the wave, its heart. A tsunami is a transfer of energy, a sudden release of force that moves through the ocean like a pulse through a living body. Unlike surface waves, which affect only the upper layers of water, tsunami waves involve the movement of the ocean from top to bottom. The amount of energy stored in these waves is difficult to comprehend. A single tsunami can release more energy than the combined power of all the storms on Earth in a given year. This energy allows tsunamis to travel across oceans without losing much of their strength. Understanding this principle helps scientists predict their behavior, modeling how energy travels across basins and where it will focus its fury. The energy behind the wave is what transforms a simple geological event into a disaster capable of reshaping human lives, reminding us of the raw power hidden within natural systems. Signs before the surge. Though tsunamis often strike without warning, nature sometimes offers subtle signs. A powerful earthquake felt along the coast is one of the clearest indicators that a tsunami may follow. Another is the sudden retreat of the sea, as if the ocean has been pulled away like a curtain, leaving fish flopping on exposed reefs. Such a sight is not a curiosity, but a deadly warning that the water will soon return with devastating force. In some cases, strange roaring sounds accompany the approach of waves, a low thunder that grows louder as the tsunami nears. These natural signs have saved countless lives throughout history, as people learned to flee inland when the sea behaved strangely. Yet, without education and awareness, these warnings may be ignored or misunderstood. Recognizing the signs before the surge is one of humanity's most important defenses against the sudden onset of disaster. Why tsunamis travel? So one of the most striking features of tsunamis is their ability to traverse entire oceans with little loss of energy. Unlike ordinary waves, which are shallow and easily broken by friction, tsunamis involve the entire depth of the sea. This deep involvement means less energy is lost, allowing the wave to continue almost unchanged for thousands of kilometers. The long wavelength, sometimes stretching hundreds of kilometers, helps it maintain momentum, and its speed often exceeding 800 kilometers per hour means it arrives quickly on distant shores. Scientists have tracked tsunamis that began in one hemisphere and caused destruction on the other side of the world. This ability to travel so far makes tsunamis a truly global hazard, not confined to their point of origin. Their journey across oceans is a chilling reminder that what happens in one region can ripple outward to affect distant lands, binding nations together in shared vulnerability to the sea's hidden strength. Tsunamis and human history. For as long as humans have lived by the sea, tsunamis have shaped history. Ancient myths speak of great floods and waves sent by gods to punish or cleanse humanity. Archaeological evidence reveals settlements destroyed and cultures altered by these sudden disasters. In the modern age, events like the 2004 Indian Ocean tsunami and the 2011 Japan tsunami are etched into global memory, their images broadcast around the world in real time. These disasters are not only geological events, but also turning points in human history, sparking advances in science, changes in policy, and a deeper respect for natural forces. The causes of tsunamis connect the present to the past, reminding us that the forces shaping our lives today are the same ones that influenced our ancestors. Tsunamis are both timeless and immediate, echoing through centuries as recurring chapters in the ongoing story of humanity's fragile relationship with the sea. The fragility of coastal life. Coastlines are places of beauty and abundance, drawing people for trade, settlement, and inspiration. Yet these same coastlines lie directly in the path of tsunamis. Fishing villages, harbors, and resorts are often built at sea level, vulnerable to waves that can strike with no mercy. The fragility of coastal life becomes clear when we see how entire communities can be erased in minutes, their history, culture, and livelihoods swept away. This vulnerability is not only physical but also emotional, as survivors rebuild amidst grief and loss. The causes of tsunamis remind us that choosing to live close to the sea comes with risks, and that those risks grow when awareness and preparedness are lacking. The fragility of coastal life is both a tragedy and a challenge, calling for stronger defenses, better education, and respect for the forces that shape the shorelines we call home. The illusion of calm seas to the casual observer. The ocean often appears peaceful, a vast expanse of blue stretching to the horizon. Yet beneath this calm lies a constant tension. The sea is deeply connected to the Earth's restless crust, and at any moment, a shift below can ripple upward to shatter the illusion of tranquility. Tsunamis are most dangerous precisely because they emerge from such calm, with no storm clouds or strong winds to herald their arrival. A tourist may gaze at a gentle tide, while hundreds of kilometers away, a quake has already sent a wall of water racing toward the shore. The illusion of calm seas has lulled countless victims into complacency, only for disaster to strike moments later. The causes of tsunamis serve as a reminder that the ocean's serenity is deceptive, that its silence is not absence of power but a mask concealing the potential for sudden chaos. the language of warning systems. Modern science has developed tools to detect the causes of tsunamis, from deep-sea sensors to satellites orbiting the Earth. These systems translate seismic tremors and shifts in ocean pressure into warnings for coastal populations. The language of these systems is technical, measured in graphs, signals, and alerts. But at its heart, it is a language of survival. Each minute gained can save thousands of lives. Yet, warning systems are not foolproof. They depend on communication, education, and trust. A message ignored or misunderstood can be as deadly as no message at all. The causes of tsunamis may be geological, but the ability to survive them often depends on the human-made systems that translate natural forces into calls to action. This language of warning systems represents a bridge between the ancient power of the sea and the modern capacity of humanity to respond wisely. The eternal dance of destruction and renewal. Though tsunamis bring destruction, they are also part of the Earth's cycle of renewal. Coastlines altered by waves may later become fertile grounds for new ecosystems. Sediments carried inland may enrich the soil, even as they devastate human structures. Islands born of volcanic eruptions may collapse into the sea, only to rise again generations later. The eternal dance of destruction and renewal is part of Earth's story, with tsunamis serving as dramatic expressions of this cycle. For humans, the destruction is personal, painful, and tragic. Yet, in the broader perspective of geology, it is part of the planet's constant reshaping. To understand what causes a tsunami is also to understand this larger rhythm of change, in which devastation and creation are intertwined. The ocean does not destroy out of malice, but moves in accordance with forces that have shaped the Earth since its beginning, forces that will continue long after us. The sudden uplift of the sea, tectonic plates collide. One often slips beneath the other, and the seafloor can suddenly jolt upward. This uplift is one of the most common causes of tsunamis, as it forces the water column above to rise abruptly. The ocean, pulled out of balance, seeks to restore itself, and in doing so creates powerful ripples that evolve into waves of destruction. The sudden uplift is not gradual. It happens in seconds, transferring enormous amounts of energy from the solid Earth into the liquid ocean. Entire coastlines can be affected by this upward motion, setting the stage for waves that can travel across seas and strike faraway lands. The uplift may be invisible to those above water, but its effects unfold dramatically as waves form and gain momentum. This simple yet violent motion beneath the sea floor becomes the first step in a chain reaction that ends with crashing walls of water against fragile shorelines. The collapse of volcanic islands. Volcanoes rising from the sea may appear stable, but their slopes are often fragile and unstable. When an eruption destabilizes these flanks, parts of the island can collapse into the ocean, creating sudden displacement of massive amounts of water. This collapse is like a stone thrown into a pond, but on a planetary scale. Entire mountainsides fall, and the sea responds instantly with towering waves. These volcanic collapses can generate tsunamis without warning, as the ocean reacts directly to the sudden intrusion of land. History records such events, where villages far from the eruption site were struck by waves triggered not by lava but by crumbling rock. The causes of tsunamis remind us that volcanoes do not only spew fire into the sky, but can also set the seas into deadly motion. The collapse of volcanic islands is nature's reminder that land and sea are deeply connected forces, always reshaping one another. The tremors of subduction zones. Subduction zones are some of the most volatile regions on Earth, where one tectonic plate dives beneath another. These zones store immense pressure, which, when released, results in powerful earthquakes. Such quakes are the leading cause of the most destructive tsunamis in history. The sudden slip of plates in a subduction zone can lift or drop large sections of the ocean floor. The water above reacts instantly, forming waves that spread outward like ripples on a drum. Countries near the Ring of Fire know this danger well, as subduction zones encircle the Pacific Ocean, creating hotspots for tsunami generation. The tremors in these regions are not just local events, but triggers for global repercussions, with waves racing across vast distances. Subduction zones are the deep scars of Earth's crust, and their restless movements reveal how intimately connected seismic forces are with the creation of tsunamis. The domino effect of Earth's forces, what causes a tsunami, is often not one isolated event, but a chain reaction of forces. An earthquake may trigger a landslide, which in turn displaces water and generates waves. A volcanic eruption may collapse a caldera, sending debris into the ocean and amplifying the resulting surge. Even small events can cascade into larger disasters when conditions align. This domino effect shows how interconnected Earth's systems are, with geology, oceanography, and atmospheric forces working together in complex ways. The unpredictability of these interactions makes tsunamis difficult to forecast with absolute precision. Scientists must consider not only the immediate cause, but also the secondary effects that could magnify the impact. The domino effect of Earth's forces highlights the complexity of natural disasters and the need for constant vigilance in understanding them. The human vulnerability. While tsunamis are natural events, their destructive power is magnified by human vulnerability. Coastal cities, fishing villages, and resorts are often built in low-lying areas that lie directly in the path of these waves. The causes of tsunamis may be geological, but the scale of disaster is shaped by how humanity chooses to live near the sea. Poor warning systems, lack of education, and dense populations increase the risks. When disaster strikes, the results can be tragic, as entire communities are swept away in moments. Yet, with better planning, resilient infrastructure, and community awareness, the loss of life can be reduced. Human vulnerability is a reminder that while we cannot stop tsunamis from forming, we can choose how we prepare for them. The tragedy of past events underscores the importance of learning and adapting to live more safely alongside the ocean. The global reach of local events. One of the most striking aspects of tsunamis is how a single local event can have global consequences. An earthquake off the coast of Chile can send waves across the Pacific, reaching Japan or California hours later. A landslide in Alaska can ripple across an entire bay and destroy distant shores within minutes. The global reach of tsunamis comes from their ability to carry energy across vast distances with little loss. This interconnectedness means that no coastline is truly isolated from the rest of the world. An event in one region can become a disaster for another thousands of kilometers away. This global reach reminds us that the Earth's oceans are one continuous body of water, and what happens in one part affects us all. The interconnected nature of tsunamis teaches a lesson of shared vulnerability and shared responsibility for monitoring and preparedness. The eternal dialogue of Earth and ocean. At the heart of every tsunami lies the eternal dialogue between Earth and ocean. The crust shifts, the volcano erupts, the mountain collapses, and the ocean responds in kind. This dialogue has existed since the planet's earliest days and will continue long after human memory fades. To ask what causes a tsunami is to ask about the dynamic forces that shape our world. Forces that never rest, never pause, and never fully reveal themselves until they erupt in sudden violence. For humanity, this dialogue is both a threat and a teacher. It shows us the fragility of our settlements, the need for respect toward natural systems, and the importance of humility in the face of powers greater than ourselves. The eternal dialogue of Earth and ocean reminds us that we live not apart from the planet's forces, but within them. Participants in a story far older and grander than our own. The anatomy of the ocean. Floor beneath the rolling waves lies a landscape as varied as the continents themselves, filled with towering mountains, deep trenches, and vast plains. This hidden geography plays a crucial role in the birth of tsunamis. When tectonic plates grind and shift, the shape of the seafloor changes suddenly, and the ocean above it is displaced. Even the smallest alteration can ripple into something immense. The anatomy of the ocean floor dictates how energy travels, how waves spread, and where destruction is most likely to strike. A sharp ridge may amplify a surge, while a deep basin may funnel waves toward distant shores. The sea, though vast and seemingly uniform, is a canvas shaped by invisible contours. Each valley, slope, and fracture has the potential to magnify or mute the waves born from Earth's fury. To understand tsunamis, one must first understand this hidden underworld, for it is the stage upon which these watery giants rise and begin their journey toward the coasts of the world. The chain of natural catastrophized tsunami rarely occurs in isolation. It is often part of a larger story of cascading natural disasters. An earthquake rattles the ground, toppling buildings and splitting roads. And then, as people attempt to recover, the ocean responds with waves. A volcanic eruption spews ash into the sky, darkening the sun, and moments later, the sea surges inward, compounding destruction. Landslides, too, may follow quakes or eruptions, displacing water and creating local tsunamis. This chain of catastrophes reveals how interconnected the Earth's systems are, each one influencing the next in a cycle of cause and effect. What begins beneath the ground may soon involve the air, the water, and human lives. This interconnectedness magnifies the chaos, turning what might have been a localized disaster into a multifaceted catastrophe. The causes of tsunamis, therefore, cannot be separated from the broader context of Earth's turbulence, for they are threads woven into a larger, often tragic tapestry of natural events. The science of displacement, the core of every tsunami, is the principle of displacement. Water is moved, and in moving it, energy is unleashed. The scale of this displacement determines the scale of the wave. When the seafloor rises, it lifts the water above, and gravity pulls it back down, setting off oscillations that travel outward. When land collapses into the sea, it pushes the water violently aside, creating a surge that rushes away from the impact. Even in the case of asteroids, the colossal splash displaces millions of cubic meters of water, creating waves taller than any human structure. Scientists model these events mathematically, calculating how water responds to sudden movement. Yet, for all the formulas, the reality remains staggering. A single shift beneath the ocean can alter coastlines thousands of kilometers away. Displacement is simple in concept, but monumental in consequence. A reminder that even the smallest push against the ocean can become a force of unimaginable power when multiplied by scale. The role of gravity when water is displaced. Gravity becomes the guiding hand that sets the tsunami in motion. The ocean, disturbed from equilibrium, seeks to return to balance, and in doing so, it releases waves that surge outward. Gravity pulls the sea downward after it has been lifted, but the inertia carries it too far, and the motion continues in oscillations. This constant pull and rebound creates the energy pattern that defines a tsunami. Without gravity, the sea might remain displaced, but with it, the ocean transforms into a living system of motion, rhythm, and power. Gravity not only fuels the initial wave, but also governs its transformation as it travels across basins and crashes onto shorelines. Every crest and trough, every retreat and surge, is a dialogue between water and the invisible force that anchors it to the earth. The role of gravity may be unseen, but it is the heartbeat behind the mighty rise of a tsunami. The shockwaves of underwater eruptions when volcanoes erupt beneath the sea. The result is often more violent than eruptions on land. Pressure builds under immense weight, and when released, it sends shockwaves through water and rock alike. Sometimes, these eruptions displace enough water to trigger tsunamis directly, while at other times they destabilize the seabed, causing landslides that lead to waves. The explosion of magma beneath the ocean can send a column of water skyward before collapsing into waves that radiate outward. These eruptions are reminders of the hidden volcanoes scattered beneath the sea, often unnoticed until they unleash their fury. The shock waves they produce resonate with the ocean itself, forcing water into motion and creating devastation that reaches shores far beyond the eruption site. The power of underwater eruptions lies not only in their fire, but also in their ability to command the sea to rise in anger. The avalanche of submarine landslides deep beneath the waves. Slopes of sediment cling to the continental shelf, fragile and waiting for a trigger. An earthquake, volcanic eruption, or even natural buildup of weight can cause these slopes to give way in massive submarine landslides. When this happens, millions of tons of rock and mud cascade downward, pushing water violently aside. The result is often a localized tsunami, powerful and fast, striking nearby coastlines with little warning. Unlike tectonic quakes, these landslides may not be detected until the waves are already upon the shore. They remind us that not all tsunamis begin with dramatic quakes or eruptions. Some are born quietly in the deep, hidden from sight, until their consequences reach land. The avalanche of submarine landslides is a testament to how even the slow buildup of sediment can set the stage for sudden catastrophe. When gravity finally claims its due, the rare fury of asteroid impacts, though rare asteroid impacts are among the most dramatic causes of tsunamis. When a massive space rock strikes the ocean, it transfers its immense kinetic energy directly into the water, creating colossal waves. Unlike earthquakes or landslides, these events happen suddenly, with no warning, and on a scale difficult to imagine. An asteroid impact can displace billions of tons of water instantly, generating waves that rise higher than skyscrapers and travel across entire ocean basins. Historical evidence suggests such impacts have reshaped coastlines and ecosystems in the distant past. While humanity now monitors the skies for potential threats, the possibility remains that one day the sea could be stirred by forces not from Earth but from the cosmos. These cosmic collisions remind us that tsunamis are not only products of our restless planet, but also of the wider universe we inhabit. The hidden fault lines beneath the sea. The ocean floor is crisscrossed with fault lines, cracks where tectonic plates meet and shift. Many of these faults remain hidden, unknown, until they rupture and cause destruction. These hidden fractures are silent threats, lying dormant for centuries before suddenly releasing their pent-up energy. When they move, the seafloor may rise or fall, displacing water and sending waves outward. Unlike surface faults, which are studied more closely, underwater faults are difficult to monitor, leaving communities vulnerable. The hidden nature of these lines makes them particularly dangerous, as they can create tsunamis with little forewarning. They are the unseen scars of Earth's crust, reminders that much of our planet's dynamics occur out of sight. Their potential to generate tsunamis emphasizes the importance of constant research and the acknowledgement that the greatest threats often lie beneath the surface, waiting silently in the depths. The pull of tidal resonance, though tides themselves are not tsunamis. Under certain conditions, they can amplify waves created by seismic activity. When a tsunami coincides with a strong incoming tide, the height and force of the wave are magnified, causing greater destruction on shore. This phenomenon, known as tidal resonance, demonstrates how different natural forces can combine to devastating effect. The gravitational pull of the moon and the sudden displacement of water caused by earthquakes or landslides merge, creating a wave stronger than either force alone could produce. Tidal resonance highlights the complexity of tsunami causes, where timing and coincidence can determine the scale of disaster. The interplay between the steady rhythm of tides and the sudden violence of tsunamis shows that nature does not act in isolation. Instead, forces join together, amplifying one another in moments that test the resilience of coastal communities. The domino effect of aftershocks, a major earthquake. The Earth often continues to tremble with aftershocks, and these smaller quakes can also trigger tsunamis. An aftershock may destabilize an already weakened seafloor or cause landslides that were delayed by the main shock. In some cases, the largest tsunami waves have come not from the initial quake, but from a later aftershock, catching survivors off guard. This domino effect prolongs the danger, making recovery efforts even more difficult. Communities that believe the worst has passed may suddenly face another onslaught from the sea. The aftershocks remind us that earthquakes are not single events, but part of a series of ongoing adjustments in the Earth's crust. Each tremor has the potential to set the ocean into motion again, extending the disaster and compounding the tragedy. The domino effect of aftershocks shows how tsunamis can be born not just once, but multiple times from a single seismic episode. The relentless energy of the ocean, even without external triggers. The ocean holds immense amounts of energy, constantly in motion from tides, currents, and winds. When disrupted by earthquakes, volcanoes, or landslides, this existing energy can amplify the waves created, making tsunamis even more powerful. The ocean acts as a reservoir, storing and transmitting energy across vast distances with little loss. Its sheer size and depth mean that once set in motion, a tsunami can persist and grow, fed by the natural dynamics of the sea itself. The relentless energy of the ocean ensures that tsunamis are not just local disturbances, but global phenomena, capable of traveling entire basins and affecting nations far apart. This energy is both the beauty and the terror of the sea, a force that sustains life but can also sweep it away when unleashed. The causes of tsunamis are inseparable from this relentless power, which underlies every surge and wave. The ripple effect of oceanic chain reactions. Sometimes, a tsunami is not caused by a single event, but by a chain reaction of smaller disturbances under the sea. An earthquake may destabilize a slope, leading to a landslide, which then triggers more underwater collapses. This domino of events displaces water multiple times, creating waves that merge into a stronger, more destructive tsunami. Each stage of the chain builds on the previous, compounding the power unleashed. The ripple effect highlights how fragile the balance of the ocean floor is, where one disturbance sets off another. These sequences remind us that natural forces rarely act in isolation. Instead, they cooperate to produce outcomes far greater than the sum of their parts. The ocean's chain reactions are silent until they culminate in towering walls of water, racing to shore. Such events prove that tsunamis can arise from a complex orchestra of forces working together beneath the waves. The sudden release of built-up pressure beneath Earth's crust. Tectonic plates grind against each other, storing energy over centuries. When the pressure becomes unbearable, the plates suddenly slip, releasing immense energy in seconds. This sudden release not only shakes the ground, but also jolts the ocean floor, lifting or dropping it dramatically. The displaced water above reacts violently, producing waves that can travel thousands of miles. This release of pressure is like a spring snapping, transferring its stored energy into the sea. Such events are unpredictable, as the buildup occurs silently, unnoticed, until the final moment of rupture. The release is both destructive and natural, part of the Earth's constant reshaping. Yet for humans living on the shorelines, it becomes a catastrophic force. The sudden release of built-up pressure serves as a stark reminder of how the slow ticking of geological time can transform into instant chaos with devastating effects. The stirring of ancient fault zones. Some fault zones are so old that they seem dormant, resting quietly for centuries. Yet even these ancient scars in the Earth's crust can awaken and cause tsunamis. When they rupture, the seafloor shifts dramatically, displacing water and setting waves into motion. These events are often unexpected, as the regions may not have experienced major quakes in living memory. Ancient fault zones carry with them the weight of geological history, and when they stir, they remind humanity that no part of the Earth is truly safe from seismic unrest. The ocean responds regardless of how long a fault has been quiet. These reawakenings are often more destructive, as communities may not be prepared for a disaster in a place thought to be stable. The stirring of ancient fault zones emphasizes that the Earth's memory is much longer than ours, and its power is never truly dormant. The collapsing walls of Caldera Lakes. When a volcanic caldera fills with water and its walls collapse, the displaced water can rush into the ocean, triggering tsunamis. These caldera collapses are dramatic, often the result of massive eruptions that weaken the surrounding rock. As tons of water surge outward, they merge with the sea, generating destructive waves. Unlike typical volcanic eruptions, these events combine both fire and water in their fury. The sudden draining of a caldera lake becomes a catastrophic trigger, amplifying the ocean's own destructive capacity. History holds accounts of such collapses, reshaping coastlines and swallowing nearby settlements. Though rare, they highlight the unpredictable ways volcanoes can influence tsunamis. A lake perched above the ocean may seem harmless, but under the right conditions, its collapse can unleash devastation equal to the mightiest quakes. The collapsing walls of caldera lakes show how interconnected Earth's features are, with mountains, lakes, and seas sharing catastrophic links. The breaking of oceanic ridges beneath the sea lie massive ridges where new crust is born as magma pushes upward. Though these regions usually spread slowly, they sometimes rupture violently, releasing energy that disturbs the water above. The breaking of oceanic ridges can send shockwaves through the sea, creating localized tsunamis. While these are often smaller than those from subduction zones, they are still dangerous to nearby coastlines. The splitting of ridges demonstrates how even constructive forces of Earth's crust, which build new land, can also lead to destruction. The ocean does not differentiate between creation and collapse. Any sudden shift beneath its depths set its waters in motion. The breaking of ridges is a hidden cause, rarely witnessed but profoundly influential. It reminds us that Earth's engine of renewal and growth also fuels chaos, and the ocean is the ever-ready medium for transmitting that chaos to shore. The collapse of glacial ice into the CAS glaciers weaken and break. Massive chunks of ice can crash into the ocean, displacing vast amounts of water instantly. These collapses, accelerated by warming climates, are capable of creating localized tsunamis that devastate polar and coastal regions. Unlike earthquakes or volcanic eruptions, these are visible events with towering ice cliffs crumbling into the waves. Yet the force behind them is equally terrifying, as millions of tons of ice hit the sea like falling mountains. The waves generated may not travel across entire oceans, but can overwhelm nearby coasts in moments. The collapse of glacial ice is a modern reminder that tsunamis are not only ancient geological phenomena, but also linked to today's environmental changes. As the cryosphere melts, the seas inherit more instability, carrying new threats for coastal communities. The collapse of ice into water is a spectacle of nature, but one that holds hidden dangers beneath its beauty. the rare shift of undersea magma chambers far beneath the ocean floor. Vast chambers of molten rock lie in wait. When these chambers shift or collapse, the seabed above may suddenly sink or rise, displacing water dramatically. Such movements are less common than surface eruptions, but no less dangerous. The sudden shift of magma chambers can act like pulling a plug or inflating a dome, disturbing the delicate balance of the ocean above. These hidden processes are difficult to detect, as they occur far below the surface, but their effects can create waves strong enough to race across seas. The ocean's power is awakened by these silent movements of magma, showing that tsunamis can be born from the hidden heart of Earth itself. The rare shift of undersea magma chambers is one of the more mysterious causes, reminding us how little we truly understand the deep. Each tremor there carries the potential to unleash unimaginable forces. The sudden tilt of continental shelves. Continental shelves are broad, shallow areas extending from land into the sea. Though seemingly stable, they can tilt suddenly when destabilized by tectonic shifts or landslides. This tilt pushes enormous amounts of water aside, generating tsunamis with frightening speed. The waves formed often crash hardest on nearby coasts, as the disturbance occurs close to land. Unlike deep-sea quakes, these events give little warning, leaving coastal populations vulnerable. The sudden tilt of continental shelves demonstrates how even the transition zone between land and sea can hold immense danger. The ocean magnifies any abrupt shift, turning geological adjustments into catastrophic waves. These shelves are reminders that the edge of continents is not fixed but living and dynamic, capable of sudden violent movement. When they tilt, the ocean becomes the messenger of destruction, carrying their instability ashore. The continental shelves, usually calm and nurturing, not one quake, but a series of smaller tremors, known as seismic swarms, can destabilize the ocean floor. These swarms, though less powerful individually, weaken the ground until it finally collapses, triggering tsunamis. Unlike single large quakes, seismic swarms can last for days or weeks, creating constant tension and uncertainty. The ocean responds to the cumulative effect, and when the breaking point comes, the waves can be just as deadly as those caused by a massive quake. These swarms show how gradual processes can lead to sudden disasters. They highlight the unpredictability of Earth's crust, where even small movements can combine into catastrophic outcomes. For coastal communities, swarms are particularly dangerous, as the repeated shaking may provide little clue about when or if a tsunami will come. Underwater mountains occasionally form or rise rapidly due to volcanic activity. This sudden growth can displace large volumes of water, generating tsunamis in the surrounding regions. Though not as common as quakes or landslides, these events are powerful reminders of Earth's volatility. The rise of a seamount can be so sudden that the water above responds violently, creating destructive waves. New islands have even been born this way, but their creation often comes at the cost of devastation to nearby shores. The sudden rise of seamounts demonstrates the dual nature of geological processes: creation and destruction intertwined. The ocean reflects this balance, responding instantly to the birth of new mountains with the fury of waves. The rising of seamounts is nature's reminder that the ocean floor is alive, shifting and reshaping itself, even today, in its growth. It creates beauty and unleashes chaos all at once. The violent impact of meteorites on the ocean. When a large meteorite crashes into the ocean, it displaces water with unimaginable force. The impact acts like a stone thrown into a pond, but on a planetary scale, sending waves racing outward in every direction. The sudden entry of mass and energy creates shock waves that shake both water and seabed alike. Unlike earthquakes, these events come from the sky, adding an element of surprise and unpredictability. The waves generated by such collisions can travel across entire oceans, arriving at shores thousands of miles away with devastating power. Though rare, meteorite impacts are part of Earth's long history, and some scientists believe ancient tsunamis were caused this way. The violent meeting of rock and water transforms the sea into a weapon of destruction. Humanity has little defense against such cosmic events, and their possibility remains a chilling reminder of Earth's vulnerability. A single impact could change coastlines forever in moments. The sudden release of submarine gas hydrates deep beneath the seafloor. Methane hydrates lie frozen in icy structures. When destabilized by heat, quakes, or landslides, they can release gas explosively. This rapid release can trigger seafloor collapse, displacing massive amounts of water. The sudden upheaval creates tsunamis that may strike without much warning. Submarine gas hydrate releases combined chemistry, geology, and oceanography into a single catastrophic event. As global temperatures rise, some fear these hydrates could destabilize more often, adding new tsunami risks. The sudden venting of gas shows how fragile and interconnected Earth's systems are. The ocean is more than just water. It is a stage where fire, ice, and gas interact. The violence of these releases, though hidden, can equal that of earthquakes. The sea turns restless, and waves roar outward from the unseen source below. The release of gas hydrates demonstrates the hidden volatility of the deep seafloor environment. The collapse of coral reefs and atolls may appear delicate, but they are massive structures of rock and skeletons built over millennia. When weakened by erosion, earthquakes, or sea level rise, parts of these structures can collapse into deeper waters. The sudden fall of these reef walls displaces water instantly, sending tsunamis across surrounding areas. While often local, these events can devastate small island communities. The collapse of reefs shows how even protective natural barriers can become threats when destabilized. Nature, in its cycles of growth and destruction, turns safe havens into sources of chaos. For people living on atolls, the ocean is both provider and destroyer, capable of reshaping lives in minutes. The sea carries the memory of every collapse, roaring with waves that strike without mercy. Coral reefs, usually seen as guardians of coasts, can transform into catastrophic triggers when their strength gives way. The unexpected consequences of human activity. Though most tsunamis are natural, human actions sometimes play a role. Large-scale underwater explosions, nuclear testing, and deep-sea drilling can destabilize seabeds. The sudden disturbance displaces water and generates destructive waves, though often smaller in scale than tectonic tsunamis. Still, these human-triggered waves can endanger nearby communities. Our pursuit of power and resources has opened pathways to disasters we once thought nature alone controlled. The ocean responds blindly to any sudden shift, whether caused by quakes or machines. The consequences of our activity remind us that human impact is woven into Earth's systems. A single miscalculation underwater can unleash a wave of destruction upon unsuspecting shores. These man-made triggers highlight how fragile the oceanic balance truly is. Humanity's reach into the deep carries responsibilities, for the seas will not forgive recklessness. The ocean answers disturbance with force, whether natural or man-made. The sudden tearing of subduction zones. Subduction zones are where one tectonic plate dives beneath another, creating the world's most powerful earthquakes. When these zones rupture suddenly, the seafloor lifts or drops dramatically, displacing entire walls of water. The result is a mega tsunami capable of crossing oceans. History records some of the deadliest tsunamis as products of subduction events. The sudden tearing of these zones is among the most feared geological phenomena. The power involved is immense, equivalent to hundreds of nuclear bombs detonating at once. The ocean above becomes an instrument of destruction, carrying energy farther than the quake itself. Subduction zone tsunamis remind us that Earth's crust is in constant battle beneath the sea. The tearing happens without mercy, without warning, in seconds that change human history forever. These events are the giants of tsunami causes, feared and studied around the world. The cascading failure of multiple triggers. Sometimes tsunamis are born not from one cause, but from many working together. An earthquake may set off a landslide, which then destabilizes gas hydrates, all contributing to massive water displacement. This cascading failure multiplies the destructive force, making the tsunami larger than any single event could produce. Nature does not limit itself to one mechanism. It unleashes chaos through combinations. These compounded disasters are the hardest to predict, as scientists must anticipate how one disturbance can spark others. The cascading failures are reminders of Earth's complexity, where every action creates ripples across systems. The ocean is the final amplifier, responding to all triggers equally. Waves merge, energies combine, and destruction multiplies. For coastal communities, the threat is not just one event, but the chain reaction of many. Cascading failures are nature's way of showing the interconnectedness of Earth's forces. The sudden collapse of fjord walls in colder regions. Fjords are carved by glaciers, leaving steep walls rising above the sea. When these walls collapse due to erosion, melting ice, or earthquakes, they plunge into the water with incredible force. The falling rock generates waves that rush down narrow fjords, magnifying their height before spilling into open seas. These localized tsunamis can be some of the tallest ever recorded, even if they do not travel far. The collapse of fjord walls demonstrates how geography itself can create unique tsunami conditions. The confined spaces funnel energy into towering waves, devastating communities along the fjord's edge. Unlike oceanic tsunamis, these walls of water strike with little time for warning. The sudden collapse is dramatic, a reminder of how landscapes shaped by ice remain unstable. Fjords hold hidden dangers, their beauty masking the potential for deadly waves. The pressure of supervolcanic eruptions. Supervolcanoes erupt rarely, but when they do, they change the world. If such an eruption occurs near or under an ocean, the displacement of material is catastrophic. Massive amounts of ash, magma, and rock entering the sea would trigger colossal tsunamis. The waves could cross continents, reshaping coastlines on a global scale. The pressure released during these eruptions dwarfs ordinary volcanic activity, creating super tsunamis never before seen by modern humans. The destructive potential lies not just in the eruption, but in the ocean's reaction to it. These are rare events, yet they remain in the realm of possibility, hidden beneath Earth's crust. The pressure of supervolcanic eruptions serves as a reminder of Earth's untamed power. Humanity has not witnessed such an event in recorded history, but when it comes, it will change the relationship between land, sea, and life forever. The shifting of hidden submarine canyons. Submarine canyons cut deep into the ocean floor, carved by ancient rivers and currents. Though stable for millennia, they can collapse when destabilized by seismic activity or erosion. When this happens, massive amounts of sediment fall into the deep, displacing water above. The shifting of these canyons generates waves that rise to the surface, spreading destruction. These hidden features of the ocean remind us that much of the seabed remains unexplored. Tsunamis may arise from processes scientists are only beginning to understand. The collapse of submarine canyons is a silent danger, invisible until the waves emerge. These hidden shifts add to the mystery of the ocean's power. What lies beneath the water can change lives above it instantly. The shifting of canyons emphasizes that the ocean floor is alive, dynamic, and capable of catastrophic change. The sudden awakening of dormant volcanoes. Dormant volcanoes may sleep for centuries, but when they awaken beneath the sea, the eruption can displace water violently. Explosions, collapses, and lava flows into the ocean generate powerful tsunamis. These volcanoes are often overlooked, their long silence mistaken for extinction. Yet the Earth's memory is long, and its fury patient. The sudden awakening of these giants can send shockwaves across oceans. The waves they produce are as merciless as any earthquake-triggered tsunami. Coastal communities near volcanic regions live under constant but quiet threat. The ocean amplifies the awakening, carrying the message of destruction across vast distances. Dormant volcanoes remind humanity that silence is not safety, and that beneath calm waters lie restless powers waiting for their moment. The shattering force of underwater avalanches beneath the waves. Slopes of loose sediment cling to the steep sides of ocean ridges and continental shelves. When these sediments suddenly give way, they create massive underwater avalanches known as turbidity currents. As the debris races downward, it displaces water with tremendous energy, creating tsunamis that can travel far from their point of origin. These avalanches can be triggered by earthquakes, volcanic eruptions, or even the simple shifting of unstable layers. The scale of the collapse can rival landslides on land, except hidden in darkness below the sea. The water responds violently, rushing outward as a chain of waves. For coastal communities, there is often little warning before disaster arrives. Underwater avalanches are reminders that even quiet seabeds can conceal sudden threats. The seafloor is not fixed, but alive with shifting masses. Each avalanche carries with it the possibility of destruction above. The chain reaction of multiple earthquakes. Sometimes one earthquake is not enough. A powerful quake in one region can trigger another nearby, creating a sequence of ruptures. This chain reaction magnifies water displacement as different seafloor segments shift one after the other. The overlapping energy produces larger and more complex tsunamis than a single quake would cause. Waves from multiple sources combine, merging into walls of destruction. These sequences of earthquakes can last minutes or hours, with each rupture adding more energy to the sea. For those on land, the ground may seem to stop shaking, only for the ocean to begin roaring. The chain reaction creates confusion, chaos, and delayed waves that strike when people least expect them. Nature's power multiplies when forces align, showing the terrifying potential of interconnected faults. The ocean records every quake, translating land's violence into water's fury. The sudden collapse of oceanic plateaus are massive undersea mountains and elevated regions formed by volcanic activity. Though stable for millions of years, they can collapse under the weight of tectonic stress. When these colossal structures give way, they plunge into deeper basins, displacing vast volumes of water. The collapse of an oceanic plateau creates tsunamis that can reach continents on the other side of the globe. The event is rare, but its destructive potential is unmatched. The ocean reacts instantly, lifting into monstrous waves that travel with relentless speed. Unlike smaller landslides or volcanic eruptions, the collapse of a plateau reshapes the seafloor permanently. Humanity would face not just a tsunami, but also a redefined geography of the oceans. These events show that Earth itself continues to sculpt and reshape its surface violently. The sudden collapse of plateaus is nature rewriting the map in moments. The violent rise of magma domes. When magma pushes upward beneath the seabed, it can create rising domes of rock and lava. These magma domes deform the seafloor, lifting it suddenly and displacing water above. The violent rise may be followed by explosive eruptions, adding even more energy to the waves. Unlike ordinary volcanic eruptions, magma domes act silently at first, pushing the Earth upward until the strain becomes too great. Then, in an instant, the ocean above becomes a weapon of destruction. The rise of magma domes demonstrates how forces far below Earth's crust shape surface disasters. The sea is never still when the crust swells beneath it. For humans, such tsunamis come with little warning, leaving survival to chance. The violent rise of magma domes is the ocean's answer to fire meeting water in the deep dot. The collapse of ice shelves into the Cean polar regions. Massive ice shelves cling to the coasts, floating partly on the ocean. When these shelves break and collapse, they displace large amounts of water. The sudden release of icebergs and fragments generates waves that ripple outward. Though often smaller than tectonic tsunamis, these events can devastate local communities and wildlife. The collapse of ice shelves highlights how climate change influences tsunami risk. As temperatures rise, more ice shelves weaken, increasing the chance of sudden falls. The waves born from ice remind us that water in all its forms can be both fragile and deadly. The collapse of ice shelves shows how interconnected Earth's climate and oceans truly are. The rare events of undersea explosions beneath the ocean floor lie chambers of gas and magma under immense pressure. When these chambers explode, the blast can rupture rock and displace water violently. Unlike gradual processes, explosions happen in an instant, sending shockwaves upward. The ocean becomes the carrier of this sudden burst of energy, transforming it into waves. These undersea explosions can be natural or linked to human activities like deep drilling or weapons testing. Regardless of origin, the result is the same: sudden, destructive tsunamis. Their unpredictability makes them especially dangerous. Unlike quakes, which can be monitored, explosions may strike without warning. The sea has no barrier to contain the energy. It amplifies it. Undersea explosions are violent reminders of the energy stored. Ridges are lines of volcanic mountains where tectonic plates pull apart. These ridges stretch for thousands of miles across the seafloor. When sections of the ridge suddenly break or collapse, the water above is displaced. The waves radiate outward, traveling far from their point of origin. Though ridges usually grow slowly, sudden breaks release immense energy. These events remind us that even constructive geological features can turn destructive. The ocean carries the signal of broken ridges to distant shores. Tsunamis from ridge failures may be rare, but they are powerful enough to leave lasting marks on coastlines. The breaking of ocean ridges reflects the balance between creation and destruction in Earth's processes. From the depths of spreading seafloors, waves rise to test humanity's resilience. The force of seafloor spreading gone wrong. Normally, seafloor spreading is a slow process as magma rises and new crust forms. But sometimes the pressure builds too quickly and sections of crust break apart violently. This rapid spreading event can suddenly shift large amounts of water, triggering tsunamis. What is usually a calm and gradual geological process becomes a moment of chaos. The ocean translates Earth's attempt to grow into waves of destruction. The force of spreading gone wrong demonstrates that even creative forces can carry destructive consequences. The balance between growth and collapse defines the restless seafloor. The sudden collapse of seamounts are underwater mountains, many formed by extinct volcanoes. Over time, erosion and tectonic pressure can weaken them. When they collapse, they send huge volumes of rock into the deep sea. This sudden fall displaces water violently, creating tsunamis that radiate outward. Some collapses may be small, but others can rival the destruction of large earthquakes. The collapse of seamounts adds to the long list of hidden tsunami sources beneath the waves. For humanity, the danger lies in the unpredictability of these events. Seamounts appear stable for millions of years, only to fail in moments. The sea above reacts instantly, rising into waves of chaos. These collapses are silent, reminders of how fragile even mountains are beneath the ocean's weight. The unseen power of mantle plumes push hot material upward from Earth's interior. When they interact with the crust beneath oceans, they can trigger volcanic eruptions and seafloor uplifts. The sudden rise of land beneath the ocean displaces water violently, creating tsunamis. These deep earth processes are nearly impossible to predict, as they begin far below monitoring stations. Mantle plumes are forces of creation, but they also bring destruction. They meet the ocean, forming shallow waters before plunging into the deep ocean. These shelves are not always stable. Layers of rock and sediment can crack under pressure. When a section of a continental shelf collapses, it sends an enormous amount of material tumbling into the abyss. This sudden displacement of mass pushes water outward in violent waves. Unlike earthquakes or volcanoes, shelf collapses are harder to detect in advance. They occur quietly beneath the sea, hidden from human eyes, until the water above reveals their fury. These collapses show that even the foundations of continents can fail, unleashing chaos. The ocean records the fall of land, amplifying it into disaster. Humanity remains at the mercy of these unstable edges of the earth. The sudden shifts of subduction zones where tectonic plates collide. One plate is forced beneath the other in subduction zones. These regions are some of the most violent places on Earth. Pressure builds slowly as the plates grind against each other. When the locked boundary suddenly slips, the seafloor can rise or sink dramatically. This instant movement displaces water, creating tsunamis that can travel across entire oceans. Subduction zones have produced some of history's deadliest tsunamis. The ocean responds as both messenger and weapon, carrying the signal of destruction to distant shores. Humanity has learned to fear these zones, but predicting their shifts remains a challenge. They are proof that Earth's surface is constantly being recycled in violent ways. The role of meteor strikes in ancient tsunamis. Millions of years ago, Earth was bombarded by massive meteorites. When these space rocks slammed into oceans, the energy release was beyond imagination. Waves hundreds of meters high surged outward, sweeping across entire continents. These ancient tsunamis reshaped coastlines and may have even contributed to mass extinctions. Though such impacts are rare, today the possibility still exists. Humanity watches the skies, but the ocean is the final battlefield where impacts translate into chaos. When the heavens fall into the sea, tsunamis carry the shock across the globe. The catastrophe of volcanic caldera collapses. Volcanic islands sometimes hide vast underground chambers filled with magma. When these chambers empty after an eruption, the ground above can collapse, forming a caldera. If this collapse happens suddenly beneath the ocean or near the coast, it displaces water violently. Entire sections of land may sink, triggering massive tsunamis. The waves rush outward, carrying the memory of the volcano's fall. Some of history's greatest disasters are linked to caldera collapses, including the eruption of Thera thousands of years ago. These events remind us that volcanoes do not only breathe fire, they also command the ocean. The sea is reshaped in moments when the earth above caves in. Humanity faces destruction, both from ash-filled skies and from roaring waves. Caldera collapses show the dual nature of volcanic power creation and annihilation in one. The tectonic rebound after major earthquakes. The seafloor does not always settle calmly. Instead, it may rebound upward or downward, adjusting to the release of pressure. This sudden rebound can create secondary tsunamis hours after the initial quake. For coastal regions, this is especially dangerous, as survivors of the first wave may not expect another. The rebound effect reveals how unstable Earth's crust remains even after releasing energy. The ocean captures this instability, pushing water into chaotic motion again. These secondary waves can sometimes be more destructive than the initial surge. Humanity struggles to predict these rebounds, leaving communities vulnerable to delayed disasters. The tectonic rebound is nature's reminder that one event may not be the end. The Earth continues to move long after the ground stops shaking, and the sea always responds. The triggering of tsunamis by gas hydrate failures deep beneath the seabed. Vast reserves of frozen methane gas, known as hydrates, lie trapped within sediments. When temperatures rise or pressures shift, these hydrates can destabilize suddenly. The result is a collapse of the seabed and a violent displacement of water. Tsunamis born from gas hydrate failures are linked to both natural processes and climate change. As oceans warm, the risk of these hidden reservoirs destabilizing grows. The release of gas adds to atmospheric warming, while the collapse creates deadly waves. The double threat highlights the interconnectedness of Earth's systems. What seems stable beneath the ocean is, in fact, fragile and temporary. Humanity must prepare for the ocean's hidden storehouses to one day fail. The sea will react without hesitation, transforming hidden gas into visible chaos. The force of double earthquake events. Sometimes, two major earthquakes occur in quick succession. The first quake weakens the crust, and the second delivers the final blow. This double strike is devastating, as the seafloor shifts in multiple stages. Each stage sends its own tsunami, and the waves can overlap into even greater surges. Coastal areas struck by one wave may be caught off guard by the next. The ocean becomes a carrier of repeated chaos, echoing the violent rhythm of the earth. Humanity has little defense against such compounded events. Seismologists study these occurrences to understand how faults interact, but the ocean's role complicates everything. Double earthquake events remind us that Earth's violence is not limited to single moments. Disasters often come in pairs, multiplying destruction through repetition. The sea amplifies the cruelty of these sequences, striking again and again. The shifts along transform faults beneath the sea. Transform faults occur where tectonic plates slide past each other. While less dramatic than subduction zones, they can still produce tsunamis under certain conditions. When sections of the fault stick and then suddenly slip, parts of the seafloor can deform. The sideways motion may also trigger underwater landslides, further fueling wave creation. These tsunamis are often smaller but can still devastate local coastlines. Transform fault quakes demonstrate that not only vertical shifts cause danger, the sideways grinding of Earth is equally destructive. The sea is sensitive to every type of motion beneath it. What seems like a subtle shift in geology becomes a violent surge of water. Transform faults extend across oceans, meaning no coastline is entirely safe. The ocean reflects the scars of Earth's sliding plates in waves of destruction. The role of human-induced seismic events. Though most tsunamis are natural, human activity can trigger small-scale events. Large underwater explosions, nuclear tests, or massive drilling operations have the potential to displace water. While these artificial tsunamis are usually localized, They prove that human influence can reach even into the ocean's fury. The possibility of unintended disasters grows as humanity digs deeper into the seabed. The ocean does not distinguish between natural and artificial triggers. It reacts with the same violent force. Human-induced seismic events remind us of the responsibility we carry when altering Earth's crust. The consequences of disturbing the seabed can echo far beyond the site of activity. The waves born of human action serve as warnings of how delicate Earth's systems are. What we create in pursuit of progress may awaken nature's wrath. The collapse of volcanic flanks into the ocean. Volcanic islands are majestic, but their slopes can be unstable. When part of a volcano's flank collapses into the ocean, it generates massive waves. This type of landslide-driven tsunami can dwarf even those caused by earthquakes. The collapse of volcanic flanks has occurred in the past, and geologists warn it could happen again. The sudden fall of rock and lava into the sea displaces unimaginable amounts of water. The waves rise, carrying the memory of the mountain's fall. For nearby islands, survival is nearly impossible without warning. The ocean amplifies the destruction, spreading it far and wide. Volcanic flanks collapsing remind us that islands are not eternal. They can crumble in moments. The sea waits to carry their fragments into walls of chaos. Humanity must respect the fragile balance of fire, rock, and water. The ripple effect of underwater fault networks. Beneath the ocean floor lies a web of interconnected fault lines, stretching like scars across the planet's crust. When one fault slips, the stress it releases can travel along this network, triggering other faults to shift in chain reactions. This domino effect can result in multiple seafloor movements across vast distances, amplifying tsunami generation. Each shift adds to the displacement of water, layering waves upon waves until the ocean becomes a rolling force of destruction. These fault networks are difficult to map fully, leaving many of their secrets hidden beneath miles of water and rock. Humanity's monitoring systems are improving, but the unpredictability of these interlinked quakes keeps coastal regions at risk. The ocean becomes a messenger of Earth's interconnectedness, translating underground fractures into walls of water. A single slip can awaken distant regions, proving the planet is far more connected than we realize. The threat of glacial calving into the CN, the polar regions. Vast glaciers stretch into the ocean, forming towering ice cliffs. When huge chunks of ice break off, a process called calving, they crash into the water with enormous force. The impact displaces massive amounts of seawater, creating waves that can travel outward like miniature tsunamis. Though smaller than tectonic-driven events, these waves can devastate local coastlines and shipping routes. As climate change accelerates glacier melting, the frequency of such collapses is increasing. This turns glaciers into silent threats, capable of sending destructive surges into the sea. Humanity often views ice as still and unmoving, yet when it falls, it speaks with the power of the ocean itself. The sea rises to carry the glacier's message, transforming melting into motion. These events warn us that warming climates do not just raise sea levels, they also unleash waves of destruction. The impact of magma movement beneath oceans before volcanic eruptions break the surface. magma often shifts and pushes through underground chambers beneath the sea. This hidden movement deforms the seafloor, sometimes lifting it or cracking it apart. The result is sudden displacement of water, leading to tsunamis even before an eruption occurs. These pre-eruption waves are especially dangerous because they strike without visible warning. The sea reacts not to fire above, but to fire below, echoing the hidden movements of molten rock. Humanity has only begun to study these deep processes with sensors and seafloor mapping. The unpredictability of magma makes prediction difficult, leaving coastal communities vulnerable. These tsunamis remind us that the Earth's molten heart is always restless. The ocean simply mirrors its shifting pulse, rising in waves that can cross vast distances. The hidden dance of magma and sea remains one of nature's most mysterious threats. The shocks from submarine explosions beneath the waves. Both natural and artificial explosions can send shock waves racing outward. Volcanic eruptions, gas explosions, or even human detonation tests create violent pressure waves. When these occur in confined spaces near the seabed, they displace water forcefully, creating localized tsunamis. Though often smaller in scale, such events can be devastating to nearby coastlines, ports, and marine life. The energy travels differently than tectonic shifts, but the sea amplifies it into powerful surges. Humanity's ventures into undersea mining and weapon testing flirt dangerously with such triggers. Nature itself also hides explosive pockets of gas or magma that can erupt without warning. The ocean accepts no difference between natural and artificial explosions. It translates all into movement. Waves are its language, carrying the message of sudden violence outward. These submarine blasts prove that both human ambition and Earth's own fury can awaken the sea. The tsunamis born from subglacial eruptions. Some volcanoes lie hidden beneath massive ice sheets. When they erupt, the heat melts vast amounts of ice, causing sudden floods known as cuckoo-plops. If these floods occur near the sea, the rush of meltwater can displace ocean water and trigger tsunamis. These unique events combine the fury of fire, ice, and water in one devastating sequence. The scale of water released can overwhelm fjords and coastlines in moments. Humanity has little defense against such sudden events, which are difficult to detect beneath ice. Subglacial eruptions remind us that Earth's layers interact in complex ways. Ice holds back the fire below until it suddenly breaks, and the sea rises in answer. These tsunamis are rare but deadly, proving that even frozen landscapes are not beyond the reach of disaster. The ocean, once again, becomes the stage where Earth's hidden forces are revealed. The cascading landslides triggered by earthquakes beneath the ocean often do more than just shift the seabed. They can loosen massive amounts of sediment along underwater slopes, triggering landslides that generate secondary tsunamis. These cascading events multiply destruction, sending wave after wave toward coasts. Each landslide adds to the chaos, creating surges that are unpredictable in timing and size. The ocean reacts violently to this falling debris, amplifying destruction already begun by the quake. Humanity has witnessed how earthquakes and landslides combine into catastrophic chains. The sea records not just one event, but many, carrying them all forward in waves. This cascading effect shows how disasters rarely act alone. They work in sequences that magnify their power. The shifting earth and collapsing slopes become a dialogue with the sea, and the message is always the same: unstoppable force, the rare phenomenon of seiche waves. In some cases, tsunamis trigger another phenomenon known as a seiche. These are standing waves that slosh back and forth in enclosed bodies of water, such as bays, harbors, or lakes. When a tsunami enters such spaces, the trapped energy bounces off the boundaries, creating prolonged oscillations. These waves may not look as dramatic as towering tsunamis, but they cause extended flooding and damage. Entire harbors can be destroyed by the repeated back-and-forth surges. Humanity often overlooks these secondary effects, focusing only on the open ocean waves. Yet seiches extend the destruction, prolonging disaster long after the first wave hits. The sea's energy becomes trapped, echoing endlessly until it slowly fades. These hidden waves reveal that tsunamis do not always vanish quickly. They linger, reshaping coastlines and lives. Seiche waves show how confined spaces magnify the ocean's fury, the influence of sudden tidal interactions, while tsunamis are not caused by tides. Their timing with tidal cycles can intensify destruction. A tsunami arriving at high tide can push water levels dramatically higher, overwhelming defenses that might otherwise hold. The combination of tidal forces and tsunami surges creates waves of unusual size and strength. Low-lying regions are particularly vulnerable. When these events align, humanity cannot control tides, making these interactions unavoidable. The ocean does not differentiate between natural cycles and sudden shocks, simply adds them together. The result is catastrophic flooding, often catching coastal areas unprepared. This interaction shows that disasters are not isolated. They combine with existing forces of nature. The tide, normally calm and predictable, becomes a partner in destruction. When joined with a tsunami, the sea, in these moments, demonstrates how layered its powers truly are. The role of crustal deformation over time. Earth's crust is constantly warping, bending, and stretching under tectonic pressure. Over centuries, these deformations build stress that eventually snaps in sudden shifts. The release of these long-hidden forces often happens beneath the sea, where massive amounts of water are displaced instantly. The tsunami is not just a wave, it is centuries of stored energy made visible. Humanity experiences the final act, but the process has been building silently for generations. These slow movements remind us that Earth is never still. The ocean is simply the messenger of stresses too vast to see. When crustal deformation reaches its breaking point, the waves rise as proof of Earth's restless nature. Each tsunami is the result of ancient movements finally finding release. The ocean is both victim and weapon of these long-term changes, carrying their story to the shore. The endless cycle of Earth, sea, and sky tsunamis are not random acts, but part of a larger cycle of Earth's forces. The shifting plates, erupting volcanoes, collapsing ice, and even meteors from the sky all play a role. The ocean translates every event into movement, carrying Earth's hidden conversations into visible form. Each tsunami is a reminder of how deeply connected the elements are. Humanity lives on the thin boundary where land and sea meet, always vulnerable to the forces below and above. The waves come not as punishment, but as the natural rhythm of a restless planet. The cycle continues endlessly, shaping coastlines, redistributing sediments, and rewriting history. Our civilizations rise and fall, but the ocean remains constant in its power. The tsunami is both destroyer and creator, taking away but also reshaping landscapes. It is the voice of Earth, the meeting of sea and sky in unstoppable motion. The sudden collapse of oceanic plateaus are elevated regions of the seafloor, often built from ancient volcanic activity. Over time, these raised sections can destabilize and collapse under their own weight. When this happens, vast volumes of water are displaced in moments, creating tsunamis that radiate outward with ferocious power. Unlike earthquakes, these collapses are silent until the sea itself responds. The ocean rushes to fill the void, producing waves that travel across entire basins. Humanity rarely anticipates these events because the collapse is hidden deep below. Yet the effects on nearby islands and coastal communities can be catastrophic. These plateaus remind us that the seafloor is not fixed. It shifts, breaks, and falls. The ocean mirrors that instability in waves of destruction. The collapse of something unseen becomes painfully visible at the shoreline. The influence of ocean trench dynamics. Deep ocean trenches, like the Mariana Trench, are sites of intense tectonic interaction. Subduction zones drag one plate beneath another, storing unimaginable energy. When these plates suddenly release, the seafloor jolts upward or downward, displacing water in an instant. Tsunamis born from these trenches are among the most powerful on Earth. The depth of the trenches magnifies the pressure and size of these shifts. Humanity monitors these areas with seismic tools, yet prediction remains uncertain. The ocean translates these movements without delay, unleashing surges that cannot be stopped. Each trench becomes a cradle of destruction, its hidden forces waiting for the right moment to strike. These tsunamis remind us that Earth's deepest places are also its most dangerous. The ocean, resting above these trenches, is both shield and weapon. The role of seafloor, spreading ridges at mid-ocean ridges. Tectonic plates slowly move apart, and magma rises to form new crust. Though this process is gradual, sudden bursts of volcanic activity can displace water. If sections of ridge crack or collapse, localized tsunamis can result. These waves may not be as massive as subduction-borne tsunamis, but they can still devastate nearby islands and coastlines. Humanity rarely considers spreading ridges dangerous, but their hidden movements can surprise. The ocean sits atop this restless seam of Earth's crust, echoing its every shift. Tsunamis from ridges are less common, but prove that any change beneath the sea can ripple upward. The spreading of Earth's floor is a reminder that creation and destruction go hand in hand. The ocean records this balance in waves that move with quiet power. The domino effect of aftershocks. After a major earthquake, smaller tremors, known as aftershocks, continue to ripple through the Earth's crust. Some of these aftershocks occur beneath the ocean and can displace water unexpectedly. While smaller than the initial quake, they can generate new waves that compound the destruction. Coastal communities, often mistake the danger as over after the first tsunami, only to be struck again. The ocean becomes unpredictable, sending multiple surges, separated by hours or even days. Humanity struggles to track these aftershocks because they vary in strength and location. Yet the sea amplifies every movement, making even small slips significant. The domino effect proves that disasters rarely come alone. Tsunamis are not a single event, but a series of echoes, each carrying part of Earth's restless energy. The ocean ensures no shift goes unnoticed. The role of atmospheric pressure waves, though rare, sudden shifts in atmospheric pressure, such as from explosive volcanic eruptions or meteor impacts, can disturb the sea surface. These disturbances create tsunami waves generated by the atmosphere rather than the seafloor. Unlike typical tsunamis, these waves are smaller but still destructive in confined bays and harbors. The ocean reacts to the air above it, translating pressure into motion. Humanity often overlooks these events, mistaking them for storm surges. Yet, the science reveals that air and sea are deeply connected. The waves remind us that the ocean does not only answer to Earth's crust, it also listens to the sky. These tsunamis may not travel across entire oceans, but they devastate localized regions. They prove that even the atmosphere can trigger the sea into violent movement. The hazard of submarine canyon collapses. Submarine canyons carve deep grooves into continental shelves, often filled with loose sediments. When these sediments shift or collapse, the water above them surges. These underwater avalanches can create destructive local tsunamis. Though smaller in scale, the danger lies in their suddenness and proximity to shore. Fishing communities and coastal towns near such canyons face heightened risks. Humanity has little warning when these collapses occur, as they happen in silence beneath the waves. The ocean reacts instantly, turning falling sand and rock into waves that reach the coast. These events reveal how unstable the seafloor truly is. The tsunamis they create may not cross oceans, but they devastate local lives. The collapse of hidden canyons reminds us that danger often lies close to shore. The impact of massive storm surges on sediment, powerful storms like hurricanes can disturb seabeds by shifting sediments dramatically. When large volumes of sediment collapse into deeper water, localized tsunamis may form. This combination of storm surge and sediment movement magnifies flooding risks. Coastal areas may face waves from both wind-driven tides and tectonic-like shifts. Humanity often prepares for storms, but not for the secondary threats they cause beneath the sea. The ocean responds to both wind above and shifting land below, layering disasters together. The waves that result carry both the fury of the sky and the instability of the seabed. These compound events prove that tsunamis are not only geological, but also meteorological in origin. The sea weathers both storms and shifts, sending their energy toward the coast. The echoes of ancient megatsunami story reveals that Earth has faced megatsunamis caused by colossal landslides, volcanic collapses, or asteroid impacts. These waves were thousands of feet high, reshaping coastlines permanently. While rare, the geological record warns us they can happen again. Humanity has not yet faced such a wave in modern times, but the risk remains. The ocean still carries The scars of these ancient events, hidden in sediments and coastal formations. Each mega tsunami was born from forces beyond ordinary scale. They remind us that today's tsunamis are only fragments of Earth's potential power. The ocean is capable of waves beyond imagination, given the right trigger. These echoes of the past are warnings for the future. The sea holds memory in its depths, and sometimes it awakens violently. The role of transform faults underwater and like subduction zones. Transform faults, slide plates, past one another horizontally. Yet sudden vertical shifts in these regions can still displace water. When large sections of faulted crust break unevenly, localized tsunamis are born. These events are less predictable, as transformed faults are not usually associated with vertical motion. Humanity often underestimates their risk, focusing on earthquakes rather than waves. But the ocean amplifies even small vertical displacements into destructive surges. Transform faults remind us that any tectonic boundary holds potential danger. The sea accepts no distinctions. It responds to every movement with waves. These tsunamis may not always travel far, but their impact on nearby coasts is severe. The hidden risks of transform faults make them silent threats beneath the ocean. The unseen forces beneath inland sea tsunamis are not limited to oceans. They can occur in inland seas and large lakes, earthquakes, landslides, or volcanic activity beneath these waters can displace them violently. The resulting waves devastate shorelines that often lack warning systems. Humanity associates tsunamis with oceans, leaving lakes unprepared. Yet history records destructive waves in places like Lake Geneva and Alaska's fjords. The ocean is not the only stage for these disasters. The pattern repeats wherever water and Earth's movements meet. These inland tsunamis prove that scale does not limit danger. Whether in vast oceans or confined lakes, water answers to the shifting Earth. The waves rise, carrying destruction into places thought safe. No body of water is entirely free from the possibility of tsunamis. The sudden rupture of subduction zones. Subduction zones are where one tectonic plate dives beneath another, creating immense geological stress. When this stress is suddenly released, the seafloor shifts dramatically, displacing vast amounts of water. Tsunamis generated here are often the largest, traveling across entire oceans with unstoppable momentum. The Indian Ocean tsunami of 2004 was one such tragedy. Humanity tries to monitor these zones with seismic instruments, yet the timing of ruptures remains unpredictable. The ocean responds instantly, sending walls of water outward from the epicenter. Every coastline in their path feels the echo of Earth's restless plates. These ruptures remind us that the crust beneath the sea is fragile and dynamic. The waves are a translation of underground chaos into surface catastrophe. Subduction zones are the greatest generators of tsunami disasters in history. The shifts of underwater fault systems beneath the ocean, countless fault lines crisscross the crust. These hidden fractures can slip suddenly, moving sections of seabed vertically. Even a shift of just a few meters can displace millions of tons of water. The resulting tsunami spreads rapidly, gaining strength in shallower waters. Humanity rarely sees the faults themselves, yet the ocean reveals their movement in waves. Some of these faults are extensions of land-based systems, continuing unseen. beneath the sea. Their activity connects earthquakes on land with waves offshore. The ocean serves as a loudspeaker for these invisible movements. When faults slip silently below, their sound is heard as a roaring wave at the surface. These underwater systems are a constant reminder that Earth is alive, shifting endlessly beneath us. The collapse of island volcanoes. Volcanic islands are often built from unstable layers of lava and ash. Over centuries, sections of these islands can collapse into the sea during eruptions or gradual weakening. Such collapses displace enormous volumes of water, creating towering waves. The feared collapse of Cumbre Vieja in the Canary Islands, for example, could send tsunamis racing toward distant continents. Humanity has studied these scenarios, but prediction is uncertain. The ocean does not hesitate. It turns rockfall into raging water instantly. Waves from such collapses are some of the tallest in history, dwarfing ordinary tsunamis. The dual power of fire and water meet in these moments, devastating coasts far and wide. Volcanic island collapses remind us that Earth's beauty carries hidden dangers. The ocean amplifies the fall of mountains into waves of destruction. The force of glacial calving in polar regions. Massive glaciers extend into the sea. When chunks of ice the size of skyscrapers break away, they plunge into the water with colossal force. These calving events can generate tsunamis, particularly in fjords and bays. Though local in scale, their waves can tower high, smashing boats and shorelines instantly. Humanity often views glaciers as slow and steady, but their sudden fractures are violent. The ocean reacts to the falling ice like a drum hit with a hammer, sending ripples outward. As climate change accelerates glacial melting, these risks may increase. Communities in polar regions must remain vigilant as ice meets sea. The waves created by glacial calving are nature's reminder of changing times. They show how even frozen giants can awaken the ocean's fury. The violence of submarine volcanic eruptions. Many volcanoes erupt silently beneath the ocean's surface. When their eruptions are explosive, they displace water with immense force. Columns of ash, magma, and steam rise, pushing the sea upward and outward. The Tonga eruption of 2022 created waves felt across the Pacific, despite its remote location. Humanity often underestimates submarine volcanoes because they are hidden. But the ocean translates their eruptions into global-scale events. These tsunamis demonstrate the link between fire below and waves above. They prove that volcanoes need not be visible to devastate coastlines. The waves from submarine eruptions travel vast distances, often arriving hours later at unsuspecting shores. The ocean is both barrier and messenger, carrying volcanic power across the globe. The Earth's vertical breathing movements, the crust of Earth, sometimes heaves upward or downward in great blocks, an action called uplift or subsidence. When this happens beneath the ocean, the water above is forced to shift. These vertical movements can generate tsunamis with incredible efficiency. Unlike sliding faults, uplift moves whole swaths of seabed, creating massive displacement. Humanity cannot stop these shifts, as they are part of Earth's natural rhythm. The ocean magnifies them instantly, turning vertical motion into horizontal waves. Tsunamis from uplift events are some of the deadliest because they move so much water at once. The sea reacts as if jolted by an invisible fist, sending waves racing outward. This vertical breathing of Earth is a reminder of its living nature. The ocean bears witness by carrying its breath as destruction. The sudden collapse of gas hydrates deep beneath the seafloor. Frozen methane hydrates lie trapped in sediments. Under certain conditions, they destabilize and collapse, causing sections of seabed to slump. The sudden fall of these sediments displaces water, creating tsunamis. Though rare, these events can produce waves of shocking intensity. Humanity has only recently begun studying these processes, realizing how unstable hydrates can be. The ocean above them reacts instantly, amplifying their collapse. These tsunamis are less predictable than tectonic ones, as gas hydrates depend on temperature and pressure changes. They reveal another layer of complexity in Earth's hidden systems. The waves created are silent warnings of the volatile substances beneath the sea. Gas hydrate collapses prove that even frozen energy can unleash watery destruction. The impact of inland fjord landslides in steep fjords. Mountains rise directly from the sea. When rockslides crash into these confined waters, the displacement creates enormous local tsunamis. Some of the tallest waves ever recorded occurred in these settings, including Alaska's 1958 Lituya Bay tsunami, which reached over 500 meters high. Humanity often sees fjords as peaceful, yet they are among the most dangerous places for sudden waves. The ocean within them cannot disperse the energy, so the water rises violently. Boats, communities, and coastlines are instantly overwhelmed. These events show how even localized landslides can unleash waves larger than those in open oceans. Fjord tsunamis remind us that scale is deceptive. The confined water magnifies their force. They are nature's way of amplifying mountain falls into towering walls of sea. The trigger of meteorite strikes in the ocean meteorites, entering Earth's atmosphere, usually burn up, but the largest can reach the ocean surface. When they strike, they displace water with catastrophic force, creating mega tsunamis. The Chicxulub impact, which helped end the age of dinosaurs, created waves hundreds of meters high. Humanity has never witnessed such an event, but the risk remains. The ocean would carry the impact's shockwaves outward instantly. No coastline would be safe from waves of that scale. These tsunamis are reminders that dangers come not only from Earth, but also from space. The sea becomes the medium that translates celestial violence into terrestrial destruction. The waves from meteorites would dwarf anything in recorded history. They prove that the sky itself can awaken the ocean's wrath. The chain reaction of multiple triggers. Sometimes tsunamis are not caused by one event, but a sequence of them. An earthquake may trigger a landslide, which worsens the wave. A volcanic eruption may destabilize a fault, amplifying destruction. These chain reactions are the most dangerous because they multiply forces together. Humanity struggles to predict them as each disaster feeds the next. The ocean magnifies this chain into layered waves, arriving in sets of destruction. Each surge carries the power of combined causes, striking harder than expected. History shows examples where one event spiraled into many, leaving devastation across regions. The sea becomes the messenger of multiple catastrophes, delivering them all at once. These compound tsunamis remind us of the unpredictability of Earth's systems. When forces combine, the ocean answers with unparalleled violence.